Hi guys, welcome to lesson 3.3, solving inequalities using multiplication or division. Our objective for today is that I can use multiplication and division to solve inequalities. Our essential understanding, just as you used properties of equality to solve equations in chapter 2, you can use properties of inequality to solve inequalities. Alright, so our example here, when we are multiplying by a positive number where c is greater than 0, our relationship will remain the same. So a is greater than b. Well, if we multiply both by c, a times c will be greater than b times c. And we can see if a is less than b, a times c will be less than b. And these are both true for equal to inequalities as well. So if it's less than or equal to or greater than or equal to. All right. And we can see it in that relationship. They are just going to be getting further apart on the number line, so the relationship will still hold true. Now, when c is less than 0 and we are multiplying, we are actually flipping the relationship. All right, so yeah, this is huge. So if a is greater than b and we multiply by a negative number, then a times c is going to be less than b times c. All right, so our inequality symbol has flipped. It has flipped. We went from greater than to less than. And this is true for less than. It goes from less than to greater than. And it'll be also true for our inequalities that are less than or equal to and greater than or equal to. This is the huge concept which we will practice in a little bit, and we'll do a little bit of a proof to show you why it works as well. All right, so for problem number 1, we are multiplying by a positive number. We want to solve each inequality and then graph the solutions. So we have c over 8 is less than 1/4. So we are going to multiply both sides of our equation by 8. And that will give us c is going to be less than 8/4, which is 2. So we have an open dot at 2. Our variable is on the left, so we can use that little hint that we are going to be shading to the left. Make sure it is clear which direction you are shading. Letter B, we are going to multiply by 2 on both sides of the equation to get rid of that divided by 2. So x is less than or equal to -6. All right, so we have a solid dot at -6, and we are going to the left. Now, you might be sitting there saying, but Mr. Boland, you just said when we multiply by a negative, we flip the inequality symbol. Well, remember, we did not multiply by a negative. The action we took was to multiply by 2, so that's okay. We still keep the inequality symbol the same. All right, letter C. We have 4 is less than or equal to 3/4 x, so we need to multiply by our reciprocal. The reciprocal is 3/4, we had 4/3. And we get 12/4 is less than or equal to x, which is 3. All right, so x is going to be greater than or equal to 3. If Ms. Zurzo likes to rewrite it in the other direction, I personally just read right to left whenever our variable is on the right. All right, so she has a closed dot at 3, and we are shading to the right.
To the right, to the right.
Not again.
Okay.
All right, moving on, why don't you guys give the top 2 a try. So 3/2 x, we're going to multiply by our reciprocal, which is 2/3. So x is going to be greater than -12/3, which is -4. So we have a closed dot at -4, and we are shading to the right.
2 stomps this time. Okay.
Letter B. We are going to multiply both sides of the equation by 10.
Sorry, I don't have a song for 10.
And x is going to be greater than or equal to 5. So we have a closed dot at 5. and we are shading to the right. All right, now, problem 2 is where you guys start to struggle because we're multiplying by a negative number. The action we are taking is to multiply by a negative number. So we're going to flip our inequality when we do that. So we have negative n over 3 is less than 1. So we're going to multiply both sides of our equation by negative 3.
Why by negative 3?
Because it cancels out the negative sign. So n will be all by itself. So n is going to now be...
I'm getting there.
Well, you added an equal to when there wasn't originally. All right, so when you do that multiplication, you switch the inequality symbol around and don't add anything to it. So n is going to be greater than negative 3. So we have an open dot at negative 3, and we are shading to the right. Now, letter B, we've got negative 2/3, so we're going to multiply by the reciprocal, which is negative 3/2.
Which will give us a positive variable.
It does. So we get a positive w is going to be less than or equal to, we flipped the inequality.
Negative 6 over 2. How about negative 3?
Negative 3. Okay, so we have a closed dot at negative 3, and we are going to shade it to the left. Okay. Now, letter C, we have negative 3/2 x is greater than negative 9, so we're going to multiply by negative 2/3. X is going to be less than negative 18 over 3, which is negative 6. So we have an open dot at negative 6, and we're shading to the left. Do you want to show them the other way of adding it? To move the negative across, to make it positive?
No.
No? Okay, fine. We won't show you the proof then. All right, letter A. Go ahead and try that one on your own.
You can keep your class in suspense with the proof.
Okay, fine. I hope you eagerly await the proof tomorrow. All right, so we multiply by the reciprocal, which is negative 3/5. And x is going to be greater than negative 9. So we have an open circle at negative 9, and we are shading to the right. Letter B, we're going to multiply by negative 4/3 on both sides of the equal sign. The inequality symbol, sorry.
That's what you get for texting and teaching at the same time.
Pretty much.
There's no variable.
Yeah, there's no variable. I think I added one in on their copy.
Is this
No,
where you want
actually I didn't. All right, so there's negative 3/4 x is going to be, you should probably write that in on yours because I copied off of this and, well, I fixed it on the digital copy.
Negative 1.
So it is going to be a positive 4. X is less than or equal to positive 4. So you have a closed dot at positive 4, and it is less than or equal to
Where there would have been an x.
less than or equal to. Oh, I did it wrong on my key. Okay.
Oh, you silly, silly man, you. Less than or equal to. This is why you don't use pen in math, Ellison. That's the second time I called him out. But it's so much fun.
Yeah.
Vegetables. Seriously, you did vegetables?
Yeah. So a student club plans to buy food for a soup kitchen. A case of vegetables, which for the record, that vegetavales, somehow Google did not spell check that one. So I blame Google. Anyways, costs $10.68. The club can spend at most $50 for this project. What are the possible numbers of cases the club can buy? And you guys get it? It's a vegetable case of vegetables. It's a phone case. Case of vegetables.
They won't be able to see that on their copy.
Oh, God. That's great. I love it. Okay, moving on. So let's start by writing our inequality. We've got 1068 times x, and x is our number of cases, is going to be less than or equal to $50 because the most money that they can spend is 50. So 50 will be bigger than anything they spend. So now to solve this, we need to divide both sides by 1068. And x is going to be equal to 4.68. So about 4 cases. If they can buy partial cases, they could get more, but 4 full cases of vegetables or less is what they could buy. All right, letter B, we have a cheerleading squad that earns $5.50 per car washed. How many cars does the squad need to wash in order to earn at least $77? So we have 5.50x is greater than or equal to 77 because they want to have more, ideally have more than $77. Divide both sides by 550. And you get that x is greater than or equal to 14 cars. All right, so they need to wash at least 14 cars in order to make their target amount. Hopefully they were all trained by Mr. Miyagi.
Wax on, wax off.
And
I don't think they know Mr. Miyagi.
they did a remake of Karate Kid, so
Did
they
they?
might know the Jaden Smith version.
Oh, I've got a good Karate Kid pose. I'll have to demonstrate in class.
Have fun with that, Ms. Urzo's class. All right.
Maybe that'll be the day I'm not there.
Problem number 4, we are going to be dividing by a negative number. So the rules still apply that we used for multiplying by negatives. So when we divide by a negative, we are going to flip our inequality symbol. So we're going to divide both sides of the equation by -5. And x is going to be less than 2, because a negative divided by a negative is a positive. So we have an open dot at 2, and we are shading to the left. Letter B, we're going to divide both sides of the equation by -2 to get x by itself, and we find that -7 is greater than or equal to x. We can rewrite that the other way and say x is less than or equal to -7. All right. Letter C, divide both sides by -4. And x is going to be greater than +7. Negative divided by negative is a positive. So we have an open dot at 7, and we are shading to the right. Okay. So why don't you guys give these last two a try. So we're going to divide both sides by -13. And then flip our inequality symbol, so x is going to be greater than or equal to -3. So it's a closed dot at -3, and we are shading to the right. Letter B, divide both sides by -9, and x is going to be less than -5. So we have an open dot at -5, and we are shading to the left. Okay? So make sure you guys fill out your level of understanding. Circle your rating, write down any questions you may have come up with during the course of this lesson. If your question is, what's wrong with my math teachers, don't write that one down.
Yeah, yeah.
And make sure you guys write down your summary of what we learned here today. So
End of first quarter is quickly coming.
okay,
Bye.
bye.